How's it going, everybody? I wanted to go a little bit more on my radio communication series, and today I want to talk a little bit about base station antennas. There are two different types primarily of base station antennas. You have a omnidirectional antenna, which would be like this one right here. It's just a stick that sticks up in the air, and it will radiate or transmit and receive equally at 360 degrees around the antenna. That is what is typically called an omnidirectional or a ground plane antenna. That one right there is an Antron 99. That is a fiberglass antenna. It comes in 3 6-foot sections, and it is made out of fiberglass, I think, as I just said. The other style you have is a beam antenna. Okay, this one right here is a 4-element. You got 1, 2, 3, 4 elements, and the configuration of this one is called a V. Okay, you can see how the elements are shaped in a V. This antenna is made by Joe Gunn. I don't know if you can see how well you can see in this picture, but this here is the back of the antenna. These radials, that's what these are called, or radials, in the back is longer than these up here. That will tell you that whenever you transmit, your signal is primarily being shot or trajected that way. Okay, that's what makes a beam antenna directional. This is taller. This acts as a rejector. It helps to reject signal and noise that's trying to come in through the back of your antenna. If I'm wanting to talk this way, well, the stuff that's coming in from the back, for the most part, I really don't want to have that interfere with me, bug me, or whatever. So I'm able to concentrate my power from my radio the way I have this antenna pointed. This right here is a rotor. This rotor is electrical powered. It has a cable that runs down into my radio room. I have a box that I can turn on, and I can actually turn this antenna via this rotor right here any direction I want to talk or listen. Okay. Now, beam antennas, there's quite a bit too, not just beams but others, but beam antennas have a rejection rating. Okay, not all antennas are created equal. There are many manufacturers of antennas out there, but you will have a rejection reading, 20, 25 dB. The antenna can reject of signal trying to get into the receive on your radio. They also have what's called a multiplication factor. Okay, depending on your antenna, how it's built, who builds it, blah, 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 there is a multiplication factor that is assigned to that antenna, and what that is a number that, let's say that you have an antenna that has a multiplication factor of 10, and let's say that your radio is putting out 4 watts. Okay, in theory, whenever you talk on that antenna that has a multiplication factor of 10, it is equivalent to your 4-watt radio putting out 40 watts. Okay, so depending on your antenna, I mean, there are antennas out there that claim to have a 65 multiplication factor, so on and so forth. But I mean, you can get you have multiplication factors on omnidirectional or ground plane antennas as well. I got this way. That's a shot of my Antron 99. This antenna, you can see my guy wires in the picture. I have it guyed. We have a lot of wind up here in Wyoming, so it's a good idea if your antenna is up in the airways that you guy it in 4 directions, to help keep the thing from snapping off. The mast, that is. The antenna itself is not guyed. Right here at the bottom of the guy wires is where the base of the antenna is. So the antenna starts like here and goes up. It's 18 foot long. And this here down is an antenna mast. It is an 1.25 inch pole that is affixed to the side of my house. That antenna at the tip is right at 52 foot in the air. Okay, that is an omnidirectional antenna. That is a very affordable antenna. And that antenna has been up in the air 10 years with zero problems with it. I say that because if you are in a windy area like I am, there are antennas out there that do not like the wind. Okay, so I know that, you know, Wyoming up here around Cheyenne where I'm at, I mean, this is really known as being a very windy. I think it's like the second or third windiest area in the country. I mean, arguably, I'm sure that there are people that have say no, you know, whatever. But you want to have it guide and up there. Now this one here, my beam antenna, is not too far off the peak of my roof. It's only about 5 foot. There's the boom over off the peak of my roof. Now I did that for a particular reason because I am not a big fan of heights. A lot of people will put a beam antenna on an antenna tower, and you can guide those towers, and a lot of radio guys will climb them towers to go up and do maintenance on their antennas. Well, I'm not having no part of that. With this being the height that it's at, I can get up on my roof, get up on my peak, and I can turn that antenna and do whatever I need to on it. Okay, so this is not at a quote-unquote optimum height, but it works just fine for me. Now, beam antenna also, the radiator on the radiators right in here, you can see the boom, and you can see this other little gizmo right here. That right there is called the gamma match. That is where the coax from your radio actually connects, is to that gamma match, or the gamma, and your radio signal goes through the gamma, and the way they're designed, it will take that signal, it runs it along these radials, and pushes it that way. The more radials you have, like you can get a 3-element, 4-element, 5, 6, 8. I mean, there's Joe Gunn makes a 8x8 star antenna, and the boom, which is this right here, the boom length on that thing is like 36 foot. So the overall length of the antenna is 36 foot long. I mean, that is gargantuan. My boom is 14 foot long. That's how long this antenna is right here. I believe it's 14 foot. I also have, and it's back here, I don't know how well you can see that, but there's an antenna back here. This one right here, and that right there is an IMAX 2000. That is a brother, big brother, whatever, of the Antron 99. They're both made by the same company. The IMAX 2000 is actually a 24 foot antenna, a 5/8 wave. I believe it's considered a 5/8 wave, and the Antron, I believe, is a half wave. Now I'm gonna get somebody screaming at me, but antenna length in many ways is rated on wavelength. One wavelength of a CB frequency is 36 feet. I'm about 95% sure on that. I'm sure there's one guy that's real good about chiming in on these videos. 36 foot is a wavelength. Okay. There's a lot of theory and stuff on the length of coax and all that kind of stuff, but I'm not going to get into all that. It can be brain numbing. I am going to go in. This right here is some information from some Mako. Okay, Mako is an antenna, CB antenna manufacturer. Okay, Mako antennas. I just went in and they have a rundown. 10 and 11 meter. These are their different styles: a Y-quad, a Comet, Shooting Star. These are different styles, different configurations of antennas. Okay. Now I did have, see, there's a flat. I did have at one time, I had a Mako 5/8 wave, omnidirectional. The Mako antennas are aluminum, which I believe aluminum antennas are a better transmitting and receiving, just a little bit better material than fiberglass. But up here I had that 5/8 wave, aluminum Mako antenna. The thing was only 20 foot off the ground at the base of the antenna, and the thing lasted 3 months. I went out one morning and the wind had literally snapped the thing in half. So from what I know, there's other guys in this town that have Makos and they've had them break as well. So if you're in a really high wind area, I don't know how I feel about the Makos, but most areas of the country are not extremely windy like we are around here. But this is what I was talking about, your gain. Okay, you got gain in dB, wind survival. It says 90 mile an hour on these. Well, I know I didn't have 90 mile an hour winds when mine snapped in half. Front to back separation. When I was talking about a beam antenna, I was saying that the longer radials on the back kind of reject signal and noise. Well, that's what this rating is right here. Okay, so that's saying that this antenna can reject 25 to 20 dB decibels of noise off the back of the antenna. It will keep it out so you don't have to deal with it. Power multiplication, 14 power, 21. Like I explained, that's what that is. As you go up, there's one that's 50, 60. As you get into these different antennas, they, generally become more money as well. You get in and start looking at Joe gun antennas, and Joe gun antennas are very expensive. But, that Joe gun V that I have up, that's been up for 10 years, and haven't had a single issue with it. Now this one happened, I got a high wind kit with it, which puts a reinforcement on the radials to help keep them from bending and busting over in high wind. But that thing has been up there and been rock solid. The bottom line on it is you can pick up an omnidirectional Antron 99 online for roughly, let's just say, 65 to 70 bucks. An IMAX is right around 100, 110 bucks. You start getting into the aluminum antennas. I believe that a Mako 5/8 is a little over 100 bucks. You start getting into the beams, and it can be a whole new ball game. I mean, Joe Gunn has beams out there that are, $2,000. So, but that's just a little bit of theory on antennas and what the difference is between an omnidirectional and a beam. Okay, this is just a general overview. This is not anything obviously that's real technical or what have you, but I'm going to take you over and I'm going to show you I have this box right here is my control box for my beam. Okay, so I can turn that on, and right now this is telling me that my beam is pointing to the southeast. Due north, east, south, west. I park it there primarily because our prevailing winds are out of the northwest. Sometimes out of the west, but a lot of times out of here, and I don't want the wind to be bucking the side of my antenna. I like it to streamline up the behind of it, or I could turn it and aim it to the northwest and achieve the same thing. But you just turn this on, I can push that down and that antenna is turning right now outside, and right now it's aiming due south. Okay, so it's as simple as that. Antenna rotors are rated on wind load and weight of an antenna. If you have a great big antenna that has a high wind load factor because it has so much up in the air, well, it's going to require a bigger, stronger rotor. You couldn't take my rotor here and put a great big 8-element antenna on it, because it would screw it up. Okay, it just isn't capable of that. So if you ever do buy yourself a beam antenna or something, and you obviously want to put a rotor system on it, make sure that the rotor is a little bit oversized for your antenna. I wouldn't get one that's right on the ragged edge. I would get one just a little bit oversized for it, to give yourself a little bit of breathing room there. But that's really about it, with the antennas. I mean, we could get into coax and all this other stuff as well, but I'm not going to do that right now. I just wanted to give a general overview. Let me say this too. An omnidirectional or ground plane antenna is a good antenna to talk locally. Okay, if you're talking to people around your town, in your city, for the most part, you'd want to be on an omnidirectional antenna. In the beam antennas, you can get a flat where my son of a guns were shaped in a V. I can't think of the freaking name of it. Well, you can get them also that lay flat. They lay horizontally flat. That's called a flat. And you can get them where they point straight up in the air. So that's a vertical. Okay. Do you ever hear anybody on the radio saying, I'm going to the flat side? That means they're switching their antenna selector box over to their flat radials. There's the word on their antenna. A lot of antennas come and they'll have vertical and horizontal, and they'll have dual gammas on it. So you'll have a gamma on the vertical and you'll have a gamma on the horizontal, and you can take your antenna switch box and you can switch between what you're going to be doing. You see right here, this says horizontal, vertical. So on my particular setup, my horizontal is what I have my beam on. Now my beam is a single gamma. Okay, so I put it on horizontal and I know I'm on my beam antenna. If I flip it to vertical, I know I'm going to my omnidirectional Antron 99. But if you're talking local and you want to talk on your beam, your best bet is to have an antenna, a beam antenna that has vertical radials on it. Okay, talking local and what have you is done much better vertical than it is horizontal. You can talk horizontal, but you're not going to talk near as well horizontal than you are vertical whenever you're talking local or what we call line of sight. The flat antennas are what's really good for shoot and skip, just because the way the signal is directed out of the antenna, it's more set up for the signal going up into the sky and getting up into the ionosphere and skipping and taking off and doing its thing. My antenna, my V antenna, is not worth a crap for talking local. It's horrible, and Joe Gunn advertised that as a DX antenna. They tell you that it's not good for ground plane or local talking, but it works real good for DX. So if I'm talking local, I'll always go to my omnidirectional Antron 99. So just a little tidbit on that as well. Wouldn't want somebody to jump out and buy a flat antenna and then try and talk local and find out that, boy, this doesn't work worth a hell. So, okay, that's about it. I'm going to cut this thing loose. Already almost 20 minutes. So thanks for listening. I hope you guys got a little bit out of this, and we'll have more of it to come. Excuse me, at a later date. Y'all take care and Happy New Year. See ya.